Good day, Algebra 2. In this presentation, we're going to be talking about permutations and combinations. In this lesson, we're going to talk about ACT information, multiplication rule, factorials, and permutations or combinations. Alright, so here's some information for you. April 18th and April 19th, you will have a test predominantly pertaining to your probability. Alright? You do have a statistical project coming soon, so please be prepared for that. And that's going to, be our last test for the year before the final. Only students who are taking the ACT on April 13th will be excused from their weekend homework. And to be excused, you have to show that ACT voucher, which many of you guys will be going to Miss Allen to ask for those, to print those vouchers. Now, if you don't have a voucher, I can't help you on that. All right, your ACT super score. So look, this is what I want to talk in the detail about. The ACT super score is based on your highest scores for each time you've taken it. For example, there's a classmate of yours who taken the ACT and is on his or her way of taking it on April. This student took the ACT December 1st and primarily focused on the math, and that student was able to score a 19, thus being exempt from tests and homework, but still responsible for all classwork and participation. All right. The student scored poorly on the other parts of it, but due to the super score, that student now knows that he or she could take it again in April and not focus on the math, but focus on the reading, the science, and all those things as well. Because the goal is to give you that super score needed. All right, so that's what that means. So for those who are 10 ACT April 13th, and you focus on math and nothing else, and you try and get that position from that final, hey, that's the way to go. Although I recommend for you to focus on all sessions. Again, focus on all sections, but again, you could take this test as much as you like. All right. So the homework for this week will be ACT centered to a certain degree. So that means most likely, because of that, you're going to have to do your work online. So if those who don't have technology at the house, well, you're going to have to find a class where you could get the technology and get it done that way. So it's imperative for you to get that part done. All right, reminder about these statistics. It's imperative for you to know this because, of course, you already have tested it on this for those who have taken the test. And for those who have been absent, you guys show up to take tests otherwise, or quiz otherwise, it's going to count against you. What is statistics? Giving that context to inspire change. That's one way of saying it. I know earlier I told you it's pretty much telling a story with a number to inspire change. And of course, the nightly news is a good example of that. Data meetings, ain't that data in particular? Your grades is, a statistic. What is data? It's just a number that tells a story. Doesn't help us with the decision making process, but it just tells a story. Your grades tell if you're a good, bad student, or if you master materials, or if you have not. Money, location, race, and the list goes on and on and on and on. There's a lot of things that could be counted as data. Alright, so again, let's compare the Precise definitions. The precise definition of mathematics tells you the technique to learn, teach, and manage reality by ciphering, counting, measuring, classifying, ordering, inferring, and modern patterns arising in the environment. This is something that I'm going to continue to test you on aggressively. Statistics, in contrast, is the technique of collecting, organizing, and analyzing and interpreting data to make decisions. Again, you had two different definitions of statistics. Make sure you know the difference from statistics versus the precise definition of statistics. Right? So, all right, the fathers of probability, you definitely need to know who they are. Blaise Pascal and Pierre du Fermat. These are people who created probability for us the way it is. All right, so let's start with this first part of the lesson, multiplication rule. So a basic counting principle is what we would call it, but I grew up calling it the multiplication principle. So when there are n ways of doing one thing and n ways of doing another, then there are m times n ways of doing both. And that's the reason why we use multiplication principle, but you can call it counting. For example, if you had 3 shirts or 4 pants, you could have 12 different outfits. When I was a kid, and I think some of you guys do this too, although you guys are in uniform. Well, when you are free dress, I grew up not having to wear uniforms. And I would do that to my outfits because most of my clothes always, could work with any other shirt I have. So being multi-purposeful, you know. So 3 times 4 is 12 different outfits that you could make. Example 1. Polly is a reporter for a high school newspaper and is writing an article about a football team. Polly wants to interview 1 freshman, 1 sophomore on the football team, and there are 2 freshmen and 10 sophomores to choose from. How many different sets of people can Polly interview? So when you look at this problem, again, I know you guys hate word problems because, oh my God, it's words and it's not you just doing a simple math to get to a number. So let's annotate this. So when we are reading these problems, when you say there are 2 freshmen and 10 sophomores to choose from, you ask for the different sets she can interview. So in this case, she could go 2, because she got 2 choices of freshmen, times 10 sophomores. And when she do that, she get 20 ways, 20 different sets of people Polly can interview. It's just that easy. Again, I know you guys be stuck on but wait a minute, Mr. Howard, Polly wants to interview 1 freshman and 1 sophomore. It's true. That's true. That is true. She wanted to choose 1 of each, but if you look at the freshman, she has 2 ways of choosing a freshman, and then she have 10 ways of choosing a sophomore. So therefore, she have 20 ways of interviewing the people. All right. So let's do example 2 together. And then example 3, I want you to kind of try it out on your own. Victor is ordering a sandwich from the deli. There are 10 types of meats to choose from, and 2 cheeses, and Victor must pick 1 of each. For the bread, Victor have 2 options. Lastly, he must choose 2 condiments. How many different sandwiches can Victor order? So here, Just get your numbers and multiply. So you got 10 meats to choose from. 10 times 2 cheeses. And then he has 2 options of bread to choose from and 2 condiments. How many customizations can he use for his sandwich? Now, it's because I got you set up, just multiply. 10 times 2 times 2 times 2. And that gives you 80 ways that Victor can choose sandwiches. So remember, because you are dealing with statistics in real life, you have to make sure that you are answering the question, not only just giving me a number, but writing me a complete sentence. Remember, you must write me a complete sentence of the work. All right, so I want you to try this one on your own. Read the problem and just try it. I'll be right back. Oh, and don't forget to pause the video and see what you can do on your own. All right. By now, you have worked this problem out. You have done it yourself, and you only plan this part to check the work. If you have not done so, please pause the video and try it out yourself. But for those who did, let's continue. So again, this is using the basic multiplication principle. Just multiply 10 times 4 times 2. And we know for a fact that should give us 80 different ways Owen can customize his dorm room. Remember, remember, you must write a complete sentence. So we could say, I'm going to do this one. Owen has 80 ways to customize dorm room. Anyways, and that's it. All right, factorials. So factorials in mathematics, we use the exclamation point. All that is telling you to do is just count down. So not count down, multiply down. So you'll multiply all positive integers from my choosing number list down to 1. And that's all you're doing. For example, when you see 5 factorial, that means 5 times 4 times 3 times 2 times 1. That's that. 4 times 3 times 2 times 1. That is also that. 3 times 2 times 1. That's that. And that's all you're doing. It's pretty easy. Not hard, well, factorial, huh? All right. So let's go ahead and put our factorial skills down. How many ways can you arrange the word July, arranging it with all the letters? So here it's going to be 4 factorial because you got 4 ways of arranging it. And when you arrange it, of course, you start counting down. So 4 times 3 times 2 times 1. Now, I'm going to show you how to do this in the calculator later on for the TI-84. And I'm also going to post videos on how to do this in decimals. So 4 times 3 times 2 times 1 is 24 ways. 24 ways. Make sure you give us complete thoughts. Right now, for the space that I have, I could only do that, but on testing purposes, I need a complete thought. So what about what about two of the letters? So it's just going to be 4 times 3, 2 of the letters. So when you do that, you're going to get 12 ways. Again, factorial means to multiply down. Okay? So far, so good. Pretty easy, right? All right, permutations and combinations. So factorials use all it's a part of all of this, so it's not completely different, and you will see. All right, so what's a combination? A combination describes the number of ways of things that can be ordered and arranged. With permutations, well, it should say with combinations. My bad, that's not true. Order doesn't matter for combination. Like for example, you see a picture of a girl with a book bag and her books to walk to school, right? So a final example of combination is you getting ready for school. I know some of you guys like to eat breakfast first, brush your teeth, take your shower, put your clothes on, go to work. Go to school. That's how you do it. You know, I like to shower first in the morning, get that one out the way. You know, eat my food, brush my teeth, get my clothes on, and I'm going to work. Again, it's various ways. I know some like to shower the night before and just wake up and go to school. Some of us like to shower the day of. But the order does not matter of how you get ready for school. So that was just an example. So this C represents combination. The N is the size of the set. And when we select, it's K. K is the selection. Again, you see the permutations of all of this, but the good news is, for statistics purpose and for Algebra 2 related purposes, just worry about putting in the calculator, you should be fine. So don't worry about memorizing this formula by heart. Just know what N is the number of the size of the set, and you know K is what's being selected, and C stands for combination. Now, to do all of this, what you want to do, you want to go to Math and Stat. And when you go to Math and Stat and click Probability, this is going to happen. I will have a video that shows you how to do that in the calculator, okay? And there's going to be a following video for you to do this in decimals. Okay, so let's try it. 3 choose 2. 3 is the number in the set. 2 is what being selected. So if you put this in the calculator, you would get 3. And this is the steps. So type in the number 3, click Math, hit Probability, type in 3, and you get this NCR, and then type in Enter, then type in 2, and this is the answer you get. Again, this is much more easier doing this in the calculator or doing this in decimals. I can show you how to do this by hand, but I'd rather not make you do that by hand. So that's the reason why we're not doing it in this video. And then these are in the calculators. The only thing you gotta know is three is what's the total set. Two is what's being chosen. So when you put this in the calculator again, you get 3, and then for 5 choose 2, you get 20. Easy. Okay, so permutations. So permutation is with ordered matter, like first, second, and third. That's a permutation. Again, it's similar to a combination. N is the number of the size of the set. K was the number that being selected. All right, so here's an example. 10 horses are running in a race. In how many different ways can the horse fit between first, second, and third? Now, I showed you the permutations formula, but you have to identify this permutation or combination. Well, it's permutation because it's first, second, and third, but you don't know about the what's being chosen. How many numbers? You don't know. You know it's just 3 places. So when it comes to this, it's just 3 factorial. Because, 3 times 2 times 1. So you have 6 ways of choosing. But you don't have to worry about that because unless I tell you the number of sets, you just go like that. Easy going. And you should know that this is a permutation. So there was no calculations really needed. I ultimately want you to identify is it permutations or combination. That's all I want you to do in these examples that we're doing so far. All right. Now let me ask you this. Is this a combination or a permutation? I want you to pause to try to figure that one out. All right, by now you should have figured that this is a combination. This is a combination because does it matter about the order I go? Should I flip the dice? Flip the die. Roll the die or flip the coin first, or vice versa. The order doesn't matter, so therefore it's a combination. And because of that, that's just that. Now, another question I propose for you to find the different possible outcomes. So, because it's a combination, you could do this. Again, for these examples, I only want you to identify combinations. So, if you are in a classroom, of course, I'm going to have you do more than that, but for the video purpose and sake, you don't have to worry about that for now. Just identify combination or permutation. All right, so read these problems yourself and identify which one is which. Pause video and try it. Welcome back. I trust that you have tried to identify permutation and combination. If you not have done so, please pause the video and try it. So your first one was permutation, and you said because your order do matter between captain and co-captain. Good job. But if you say rob them in the 13 countries was a combination, you are indeed a legend because your order do not matter. It doesn't matter what countries they go first. They go to France first or they go to Cuba first. Does not matter. All right. Now, we identify stuff, but now we got to do it with various methods. with or without repetition. So we know for a fact by looking at this, we know that when we're dealing with the pen, it is a permutation or the mouse. But in these examples, I want you to actually do the work. So here, you're not going to use the permutation formula. There's no need for it. So here, you try to find a pen from your bank, ATM machine, your 4-digit pen with replacement. So that means that you could have 4 zeros if you want that. Or you could have 17257 if you want. You could do any of those combinations, or it does not matter. But here, because it's saying 4 digits, 4 digits with replacement. So that's how many digits we have? We have 10 digits. So 10 to the power of 4, that's going to be 10,000. Because you could repeat all day, every day. So what about a pen that is made up of 4 digits and 3 letters without replacement? So if it's without replacement, obviously you're going to use just your basic number of permutations, count down. So in your first 4 digits, it's going to be 10 times 9 times 8 times 7. And then if it's an N, we know for a fact N is going to mean multiply. So multiply, I'll get this together. And then for your letters, because that's 26, 26 times 25 times 24 times 23. Because when you take a letter, you have less options. So if I had started off, if I select one letter, I got 26 options. But if I select two, there's 25 options. So just multiply these together. 10 times 9 times 8 times 7. That's going to be 5,040 times 26 times 25 times 24 times 23. 25, 358,800. And of course, just multiply these two numbers together, and you should get your answer. I'm not going to do it here because I got no space. And I think you are more capable of multiplying. All right, so why don't you try this problem on your own? Pause the video and try it. Okay, by now I know that you have did this problem. And so let's go ahead and do it. So everything could be repeated. So 3 letters. So that's 26. Because the letters can repeat. 26 to the power of 3 because the exponent is repeated multiplication. And because the digits can also repeat, it's going to be 10 to the power of 3. So that's how you do that problem, and you guys calculate that yourself. So when they cannot repeat, 26 times 25 times 24. So when you multiply that, and this is times 10 times 9 times 8. And when you multiply all that, you should get an answer. Pretty easy lesson, huh? Not bad, eh? Well, that was your lesson for today. Make sure you guys do all your digital assignments I give you. Make sure you guys are in pair/extra labs to get things situated.